Alrighty guys, and here we are with the last part of Unit 9, which is dividing radicals. You have learned how to simplify radicals, add radicals, subtract radicals, and multiply radicals, and today it's time to divide. So the things to remember are your 4 steps here at the top, and you can look back at them whenever you need to. Step 1 is to break apart the radicands using the quotient rule. And the quotient rule is the square root of a divided by b is equal to the square root of a divided by the square root of b. All right, so you can break apart the numerator and denominator that are all underneath one radical sign. Then you're going to look for perfect square radicals and simplify them. So you need to be able to identify perfect squares. If you need to keep a list of them nearby, certainly you can do that. We can write them at the top of the page here so that you don't forget what they are. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, 289, 324, 361, and 400. So if you have that list nearby, that will help you. You're going to simplify your perfect square radicals. Then we're going to simplify the radicands. And I'll show you how to do that in just one second. Finally, you're going to simplify the resulting radical along with any coefficients. So this step 3, let's think for a second about simplifying just a regular fraction. If I had 2/10 and I were going to simplify, I know that a number that could be divided into both 2 and 10 is 2. So I would divide by 2, and I would get 1/5, okay? It is the same thing for simplifying radicals, okay? But you would do like this. Well, what if this was the square root of 2 and the square root of 10? You're not going to divide by 2, you're going to divide by the square root of 2. The square root of 2 divided by the square root of 2 is 1. 10 divided by the square root of 2 is the square root of 5. So you see the difference here is that we're going to end up keeping our radical sign, but you can simplify radicals the same way you can simplify regular fractions, and that is going to come in very handy in just a moment. Let's go ahead and do some example problems. And I'll try to go a little bit slower than I normally do because for this one you got to kind of wrap your brain around it a little bit. So remember that step 1 is to break apart your numerator and denominator. So the square root of 49 over 100 is equal to the square root of 49 divided by the square root of 100. Now here's where you need to recognize, hey, I see 2 perfect squares. The square root of 49 is 7, and the square root of 100 is 10. Now 7/10 cannot be simplified any further, so that is your answer. Taking a look at number 2, we're going to separate the square root of 8 over the square root of 32. Okay, now the square root of 8, neither one of these numbers is perfect square. So what we need to do then is break them both down and see if we can simplify them. So 8 breaks down into 3 2's. 32 breaks down into 5 2's. And we're going to simplify them separately. So 8, we got a pair of 2's here, right here. We'll bring it out front. I have 2 pairs of 2's here. So if I take out a 2 and another 2, that's going to be 4. All right, and now I can look at simplifying here. 2 divided by 4, 2/4 is the same as 1/2. And square root of 2 divided by square root of 2 is just 1. So your answer actually turns out to be just 1/2. Okay. Now, let me show you another way to do this problem. As always, there are multiple ways to come at the problems. I'm going to leave that up there. The other option we might be able to do is we can look at this fraction, 8 over 32, and say to ourselves, I know I can simplify that fraction. Let me leave it as a big giant square root. And if I were to simplify 8 and 32, I could divide by 8. And this would be 1 over 4. And then I recognize that 1 and 4 are both perfect squares, and I can get to 1/2 that way also. All right, so two different ways to do it. You can either, when you have a fraction that doesn't contain perfect squares, you can simplify it first if possible, then break it apart, or break it apart and do your factor tree. Let's come over here to number 3. So using what we just said, 3/16 is not going to simplify because 3 does not go into 16. So I am going to need to break this one up. And I can't do anything with 3, but I can break down 16. And I'm going to have 4 2's. So keep square root of 3, 2, 2, 2, 2. Take out a pair of 2's and another pair of 2's. The square root will be gone, and I'll have square root of 3 over 4. And this is our final answer. Take a look at number 4. 7/49. I recognize right away that 49 is a perfect square, so I'm going to break this up. Square root of 49 is 7. And then looking at my numerator, 7 is a prime number, so I know it doesn't break down, so this is my final answer. Guys, this is not 1. And the reason is because you have a radical in the top and no radical in the bottom. Remember, that top number is the square root of 7. It is a number times itself that actually equals 7. It's going to be 2 point something or other. And 2 point something or other divided by 7 is not 1. So be very, very careful here that just because you see 2 7's does not mean you can cancel it to make 1. If one of them has a radical, that doesn't really mean 7. It means a number times itself that equals 7. All right, don't fall into that trap. Let's take a look at this one. So number 5 is interesting because 10, square root of 10 and square root of 45 are separate. But I know that 10 and 45 can both be divided by 5. So remember what we said about simplifying fractions if they've got radicals. I'm going to simplify. I'm going to divide both of these by square root of 5. Not 5, square root of 5. And square root of 10 divided by square root of 5 is square root of 2. And square root of 45 divided by square root of 5 is square root of 9. Because remember, think about it. If we go the other way, we already talked about the product rule, how you just multiply the 2, right? So I can break up the 2 the same way. Well, now I know that square root of 9, that's a perfect square, which is equal to 3. And here's my final answer. Let's look at number 6. Number 6, square root of 36 is 6. I know that that's a perfect square. Now, before I say, okay, I'm done, let me see if I can break down 12. And I can. So square root of 12 is really square root of 2 times 2 times 3. If I pull out a 2, all right, when I get to this point, though, look at my coefficients. 2/6 can be simplified to 1/3. And we normally don't write the 1. So here would be your final answer on this one. Let's take a look at number 7. Square root of 96 and square root of 3. I know that 3 does go into 96 because 3 goes into 9 and 3 goes into 6. So I'm going to simplify by dividing by square root of 3. Remember, if you're going to simplify radical, you have to divide by a radical, not just divide by a regular number. So you don't just do divide by 3, you divide by square root of 3. So 3 into 96 is 32. So this is square root of 32. And square root of 3 divided by the square root of 3 is 1. So this is just square root of 32. And let's see if we can break it down. which we can. So this is really square root of 5 2's. I've got a pair here and a pair here, so 2 times 2 is 4, with 1 2 left over. There's my answer. Okay, let me do a couple more for you. Let's look at number 8. Why don't you pause here and try this one, and then start me up again when you think you have your answer. All right. I know that 6 goes into 108. I could do on my calculator 108 divided by 6 and see that it really does go. It's 18. So this is going to be, I'm going to divide by square root of 6, divide by square root of 6. I keep the coefficient. It's the radical that's being divided. And of course this is 1, so I just have 7 square root of 18. And I'm going to take my 18 and break it down. So I have 3 times 3 times 2. A pair of 3's comes out. That's going to bring out a 3. That's going to give me 21 root 2. How'd you do? Hope you got it okay. Let's do a couple more. I'm going to skip down to number 11 here. Number 11 is interesting because we've got coefficients on both of our radicals, but that's no big deal actually. I can simplify 10 divided by 2. What is 10 divided by 2? It's 5. You can put it out front, or you can put it in the numerator next to the square root of 48, however you want to do it. But I'll tell you what, I know that 3 goes into 48, and if you don't know that, you can always get out your calculator and try. Like, can I divide this by 3? You'll find out that it's 16. So we'll divide by square root of 3. Remember, a radical has to be divided by another radical. So this is going to be square root of 16, and square root of 3 divided by square root of 3 is 1. So this is still going to be 5 root 16. Well, square root of 16, that's a perfect square, is 4. So this is really 5 times 4, which is 20. Let's move over to number 12. Why don't you pause the video and try this one and start me back up when you think you have your answer. All right, so looking at this one, I know that 3/15 is equal to 1/5 if I divide by 3 and divide by 3. I know that 7 times 12 is 84, so I can divide by square root of 7. And so square root of 84 divided by square root of 7 is square root of 12 over 1. So this is really square root of 12 over 5. And if I break down the square root of 12, it's square root of 2 times 2 times 3. I can take out a pair of 2's. So this is 2 root 3 divided by 5. All right, hope you did good on that one. Once, I think what I'd like you to do is go through and do 9 and 10. Once you have the hang of this, let's talk about what it means to rationalize the denominator. So it's not really considered correct form to have a radical in the denominator. We prefer not to have that. So instead of having a radical in the denominator, we want to get that out of there. What we're going to do is multiply both the numerator and denominator by the radical that's in the denominator and simplify, because here's why. Square root of, for example, square root of 2 times the square root of 2 is the square root of 4, which is 2. Square root of 3 times the square root of 3 is the square root of 9, which is 3. Do you see how your final answer is the same as one of these radicals, right? So if I take the number and square it, I'm basically doing a square root squared. Square rooting a number and then squaring it are opposite operations, and your answer is the number, your radicand that you started with. So that's how we can eliminate a denominator that we don't want, a radical denominator. Let's see this in practice with number 13. Maybe it'll make more sense. So I have 4 over square root of 7. 7 is a prime number. I can't break that down any farther. There's nothing to simplify the 4 with. So let's say we did a problem and this was our answer. We don't want a square root in the denominator. So what we're going to do is multiply the numerator and the denominator by that square root. Well, the square root of 7 times the square root of 7 is the square root of 49, and the square root of 49 is 7. So we could just take our radicand and say that's our answer. Now, as you can see, it complicates the numerator. The numerator has more stuff in it than it used to, but that's okay because what we want is no radical sign in the denominator. Take a look at number 14. Square root of 5 divided by square root of 2. Neither one of those are perfect squares. Neither one can be broken down, but I don't want a square root of 2 in my denominator, so I'm going to multiply everything by square root of 2. The square root of 5 times the square root of 2 is the square root of 10, and square root of 2 times square root of 2 is just 2. And remember, you cannot say that this is 5. All right, you have a radical in the numerator and no radical in the denominator. Square root of 10 divided by 2 is not 5. The square root of 10 is really 3 point something something something. It's a non-terminating, non-repeating decimal. And 3 point something divided by 2 is not 5. So be careful, don't fall into that trap. We'll try 1 or 2 more here, and then I'm going to let you go on your own and try these out. Let's take a look at number 15. I recognize that 81 is a perfect square. So I'm going to break this up, and I'm going to go ahead and simplify it. Now I have gotten as far as I can go, but I don't want the square of 2 in the denominator. So I'm going to multiply both numerator and denominator by square root of 2. And this is going to be my final answer. Let's see if we can find one that's just a wee bit more complicated. They're really not too bad. Let's look at number 21. These are not too bad. I have a coefficient of 4 and a coefficient of 6. I know that those can be simplified. 2 will go into both of these. So this will simplify to 2/3. Now I don't want the square root of 2 in the denominator, so I'm going to multiply both by square root of 2. This 2 will stay. These 2 multiply together to become root 10. This is going to stay. These 2 will multiply together to make 2. Now I can simplify again because 2 divided by 6 is 1/3. So this is going to be square root of 10 over 3. All right. So go ahead and give these a shot. Work all the way down to number 24. Check your answers. If you're having problems, please email me. I'll be happy to walk through it with you. When you're done with that, go ahead and try the next page. It's got 2 pages on it. It goes all the way to number 24. Try all those problems and check your answers as you go. As always, email me if you have any issues. This is the last thing for Unit 9, you guys. So when you're done with this, you will have learned everything that we missed from not being in school in April. Okay? So catch you next time.